I want to show you a reconstruction of a tsunami that occurred on the 17th of July 1998 off the coast of northeastern Papua New Guinea. Okay, it's a little map shown here, and you can see the epicenter of the tsunami, and it was actually located very close to the coast, 50 kilometers from the coast. And you can already imagine that there was no way to warn villages. Yep. So for orientation, as you can see, the north points here along this red arrow, and Australia is sort of located here in this location. Okay? What I want to show you is just how does a tsunami look like in terms of the waves that are created. And it's actually very, very similar to the situation if you throw a rock into the water. You just go to a lake, throw a rock into the water, and it actually creates initially a circular wave. So these type of waves, they have a short, relatively short period, and they're not influenced by the Coriolis force. Let's see how it looks like here. Start the simulation. I probably have to click here. It starts, you see the initial wave, and the wave actually doesn't have enough time to turn parallel to the coastline. You actually see a wave that propagates along the coast. It doesn't come as a single wave. It creates actually a sequence of waves. And you experience something similar if you throw a rock into the water. It's not a single wave, but a sequence of waves. And indeed, the seismic activity is also irregular. It's not only one initial burst. It comes in a sequence. Okay, you can see the wave propagates, and it becomes affected through reflection by islands at coastlines. Okay, there's refraction, which is the change of the propagation direction, and also reflection of coast. So you can see that these islands in particular protect Australia from the waves progressing further. Okay, and this is the situation shown after 2 hours. 120 minutes is 2 hours, and you can already see that there's no way you can warn the villagers, and nearly 3,000 villagers lost their life. Okay, so this is one example. It is relatively easy to predict these waves with computer-based models. What is very difficult is to predict the generation of a tsunami, to predict the earthquake that leads to it. Okay, so you learned that the propagation speed is so fast that it's almost impossible to create warning systems. Okay, for tsunamis, a very, very tricky business.